Okay, today we're talking about the Doppler effect. Woo! Don't worry, it's not as stormy as it sounds. So what is the Doppler effect? Meow. The Doppler effect is when the frequency of a wave, we're going to talk about sound here, changes from motion. Ta-da! Okay, so what do we mean by that? What we mean by that is, let's draw a picture. So here's an ambulance. Isn't it pretty? Here's you. You're standing here. Now, the ambulance is going to have its siren on. Wee, woo, wee, woo, wee. So let's pretend here's the sound wave coming off of the ambulance. And here's the sound wave coming off the ambulance. If the ambulance were parked, these would be perfectly evenly spaced. And they'd be perfect spheres, right? So the distance between them would be something. I'm going to call it D, right? So this is on the different sound waves. But here's the dealio. Since the ambulance is moving forward at a particularly high rate of speed, as this wave is traveling outwards, this wave has a head start on there because the ambulance is more forwards, okay? So let's pretend here's my ambulance siren. It's moving this way. So this wave goes out, and then the ambulance is over here, and this wave goes out. But this wave moves forward, so they're going to be closer together, all right? So as the waves hit you, because the ambulance moves forward as it's throwing them out, you're getting hit by these waves more often. Now, since this distance is much shorter than the distance over here, this is going to sound higher than it did before. Okay? Now, let's talk about the other point of view here. So if you are standing there and the ambulance drove by and it's on its merry way, it still has its siren on. It's still going to make the sound waves. But this time, what's going to happen is you're on the opposite side. So as the waves go, the ambulance gets further away from you. So each wave is going to be stretched out more. All right? Because each one of these circles has a center that's moving to the right. All right? Now, this will make it sound lower. It will sound lower because there is a lower frequency. Remember, it's all about the frequency. So because you're getting hit by more waves per second, in this situation, it's going to sound a higher pitched. Because you're getting hit by less waves per second, it's going to have a lower pitch. Now, if you were sitting in the ambulance because you had your arm ripped off, you would not hear the ambulance change pitch at all because the waves from the siren are hitting you at a consistent rate every time. There's no change because the siren isn't moving with, compared to you. All right. So there is a wonderful formula for this, okay? Now, there's two things you got to worry about. One is there's a frequency of a detector, and the second is a frequency of the source, right? So this is the source frequency, and it's going to be in hertz because that's what frequency is measured in, and this is the detector frequency, which is also in hertz. Okay, so we're going to multiply it by one thing. Well, I'm lying to you. One thing that's a big thing, all right? So it's going to be V minus VD and V minus VS. Okay, so what are all of these? Well, these V's are the same. These are the speed of sound. So you should know what that is from yesterday. Speed of sound, which is going to be around 340 meters per second. All right? The VD is going to be the velocity of detector. We'll get detector, whatever. And this one is going to be the velocity of source. Both of these are going to be in meters per second. Now this is how each thing is moving. So your ambulance movement would be here, and if you were moving at the same time, that would go over there. Okay, and that's the formula, and that's it. So let's think about some movement here. If a second ago we were standing still, right, our velocity of detector was 0, so that's going to be a 0 here. And let's say the ambulance was driving at 100 meters per second, just to make it easy here. This is 340, and this is 340. These are always going to be the same. You're going to have 340 divided by 240. Okay? Now, that means that it's going to sound higher because it's moving towards you. Okay? Now, something you need to be aware of is the signs are towards or away. We're going to talk about that in a second once we have a specific example here. But you're going to have to be very careful about those minuses. Sometimes they're going to be pluses and sometimes they're going to be minuses. Well, really the V's will be positive or negative, but let's look at one together. You are chasing your friend at 6 meters per second while they are running in front of you at 4 meters per second. Let's draw a picture. Here's you. You're running at 6. Your friend is running at 4. You yell at 520 hertz. 520 hertz. What is the sound that they hear? They're not going to see, they're not going to hear 520. So we need to use the formula. So F is equal to 520 times, alright. Now, sound is traveling this way, and it's going to be traveling that way at 340. 340. Okay? Now, you are running the same way as sound, so we're just going to plug in your number, because that's a positive number, so you're traveling the same direction. Your friend is also traveling the same direction, so we are going to put their number there. Oops, I mixed them up. My bad. Right? Ta-da, so far so good. So what we're going to do now is we're going to put it in our calculator. Well, let's think about it first. We get 520 times 340 minus 4 is going to be 336 divided by 340 minus 6, which is 334. So we should get a number that's bigger than 520. And does that make sense? Well, let's type it in first. 520 times 336 divided by 334. Enter. So you get 523. Now, this is higher. Does it make sense to be higher? Yes. You are moving towards them. You are gaining on them. Whenever you're moving towards something, you should sound higher. If you don't get a sound that sounds higher, you might have screwed something up. Let's do another practice. Person yells at 6:10 while running at you at 5. So let's draw this picture here. So they're running at you. So they're running this way at 5 meters per second. You run at them. Ooh, sounds romantic. At 8 meters per second. And they are yelling at you. So here's the sound waves at 340. Alright, what's the pitch that you hear? So we're going to set it up same kind of way. F is equal to the F of them, which is 610. Alright, and 340 and 340. Alright, see if you can finish that fraction. Pause the video, go. Alright, well, let's think about it. So we're going to have 8. 8 is for you. You are the receiver. So you are going to be down there, or up there. And 5 is going to be over here. Now, The 5 is moving the same direction as the sound, so it's going to be a positive 5. But you are moving the opposite direction, so that's going to be a double negative. So it's going to become 348 at the top. So 610 times 348 divided by 335. Ta-da! So what we got here then, let's type it in. 610 times 348 divided by 335. Enter, you're going to have 633.7. 634 is good enough. Hertz. And does that make sense? Yes, it needs to be a higher pitch. You'll notice that it's significantly higher because you are running at each other now. Okay, I think we have one more. Yeah, piano is tuned to 440, but you are running away. Just like from your problems, right? Until it sounds like 415. How fast are you running? So a little bit different flavor, but it's the same thing. We know what we're hearing. We're hearing it at 415, and that's going to equal 440 times this part. Let's see if you can set it up here. 3, 2, 1, go. All right. Did you do it? So we're going to have 340, 340. Right, minus, minus. Well, the piano ain't moving, so this is going to be a 0, and that's going to be a V. So we're just going to solve for that V. Okay, so I'm going to divide both sides by 440. So that way I get 415 over 440 is equal to 340 minus V over 340. Alright, so I'm going to multiply this guy out too. So I'm going to get 415 divided by 440 times 340. Enter. So we're going to get 321 is equal to 340 minus V. And doing some quick math here, I know that V is 19 meters per second. You run pretty quick. Hey, so that's the kinds of things we're going to be doing. So you're using the same formula, but you're solving it both ways, sometimes for the frequency and sometimes for the velocity. But you have to know the other stuff too. But the hardest part is definitely the setup. Hopefully you're feeling okay with this. There's a little bit of practice there for you. Have fun.